Central angles equal arcs and arcs equal central angles. Let's take a look at our pizza here. It's a decent size, but 3 people ate this pizza. Well, this big slice is represented by 158 degrees. This 158 degrees is a central angle. All right, it has 2 radii going this way, the vertex being the center point. And however far wide this opens will determine how much this person ate. So if the central angle was 158 degrees, well, this person ate a total of 158 degrees of the pizza. Moving clockwise, we will go over to the next person. They ate 9x plus 7. But what do we know about that? That the arc is also 9x plus 7. So I'll put that on the outside. You do not have to. Then we're going to shift over to our pink here and highlight our 6x plus 15, which they're giving us an arc, but we know that the arc equals the central angle. Now, in order to solve for x, we will take either the 3 arcs or the 3 central angles, which are all the same, and set them equal to how many degrees is that pizza? Yes, 360 degrees. We will start with our 158, just like what we did when we were identifying here. And then we are going to add 9x plus 7 to it. So plus 9x plus 7 plus 6x plus 15. And we are going to set that equal to our pizza of 360 degrees. So we wrote the equation equal to 360. The next thing we need to do is, yes, combine like terms. So again, we are simply using all of that algebra skills. They're coming into play. I'm going to circle the 9x. I like to start terms with variables first, and I can combine that with, great job, the 6x there. 9x plus 6x gives us, great job, 15x. I will box my 158. Plus 7 is 165. Oh, plus 15 equals 180, which equals 360 degrees. Okay, now sometimes we might be adding constant terms from both sides depending on if our constant, if this were a negative 180, we would add 180 to both sides. But we will subtract constant from both sides. It's day 1. I kind of want to break it down in its simplest form for us. So let's go ahead and subtract 180 from both sides in order to get that 15x by itself. We will bring down that 15x. Yes, my little cursor here kind of got in the way, and that's why it came out on a slight angle. But 360 minus 180 gives us 180. Our last step is to divide by the coefficient, the number in front of the letter. This time is 15. 15 divided by 15 is 1. I draw that giant 1 on a diagonal. Pull down our x. 180 divided by 15. Well, if 10 times 15 is 150, add another 30, so that would be 12. Let's go ahead and circle our answer. And for those taking notes at home, yes, that's what it should look like for your first one. Let's try number 2 together. Oh my goodness, there's more pieces in this pizza. How many students ate this pizza? Well, let's just go ahead and give it a go. I like to start with the whole number there. Now this 48, what is that to you guys? Great job. It's a central angle. And what do we know about the arc? Yes, it equals the exact same. And again, I'll put that on the outside just so you guys can see that. And now I will move over clockwise to 107 degrees, which is represented by an arc, which also means our central angle opened up to 107 degrees. Continuing on, I'll switch over to pink clockwise, 5x plus 4. We have that nice little central angle there. I'll zoom in tight, and I'll put our 5 x plus 4 along the outside, representing that arc that goes with it. And we will carry on in teal. We have the 70 degrees here of a central angle. Well, then we know its arc is also, yes, 70 degrees. This is to build that comfortability. All right, I'm going to highlight our arc of 7x plus 35, and then I will write in that central angle of 7x plus 35. We can pick any of these from where you want to start. I'll start with the 48 because that is what we began with. You do not have to. You can pick any of these. Just make sure to go clockwise with it. You can go counterclockwise, but that might confuse you later because I'm always looking at a clock going clockwise. I know, a little crazy here. Maybe I'm just a little much. So we'll take that 48 in gray. We will add the 107 to it. I'm writing this a little smaller to save for space. We will also add our 5x plus 4. Followed by our 70, as well as our 7x plus 35. Yes, I wrote that kind of small. I will zoom in just a moment. I do want to set that equal to, though, how many degrees? Yes, 360 degrees. And then step 2 will be to combine like terms. So we wrote our equation. This is what we have. We will combine like terms. Again, I always like to kind of look for the variables here. I'm going to circle my plus 5x. What can I combine that with? Oh, yes, great job. Plus 7x. 5x plus 7x gives us how many x? Wonderful work. 12x. Then I will work through our constants. 48 plus 107 is 155. 155 plus 4 is 159. 159 plus 70 is 229. 229 plus 35 is, let's see, 264. It should be. You guys might want to double check my math. I really hope I don't need to start over. But again, our step in blue here. So we combine like terms. Now we will subtract constant term from both sides. I created this way because we're still kind of learning and growing. All right. We want to continue to give light and water to our plant. Just like our learning, we need it and want it to grow. 12x, we will go ahead and bring that down. Again, top to bottom, left to right. 264 minus 264. Nobody home. Bring down your equals. 360 minus 264 is 96. And our last step, guys, divide by the coefficient. So that's exactly what we're going to do. Divide each side by 12. There's that giant 1. Bring down your x equals 12 times 4 is 48. 48 times 2 is 96. We used 8 of those 12s to get to 96. Go ahead and circle your answer. If you're taking notes at home, guys, yes, our setup and our solve should look exactly like this. Build your confidence with it. Moving forward, I did something a little different because if we know that, well, an entire circle here equals 360 degrees, our pizza, well, guess what? Let's just say Mr. Richards came on in, and he decided to knock down the 120 and the 60, which is 180 degrees. Yes, I am going to do this in gray and run it through a little thicker because right here is a diameter, all right? It starts on the outer edge of the circle, it cuts through our center point, and it ends up on the other side of the circle. It's supposed to stop there and stop there, but that cuts it directly in half, so we can get rid of those two pieces. Wonderful. So the students then were like, we only have half a pizza left. And then someone decides to scoop on in and eat 109 degrees of that pizza. But we also know that arc at 109, its central angle is also 109. Great job. And again, I will continue clockwise. 4x plus 8. Well, if our central angle is 4x plus 8, the arc is also 4x plus 8. Let's write that in. Oh, we're just going to skip this half. Mr. Richards already ate it. And then we have the 6x plus 13 here in teal, which is our central angle, and its arc is also 6x plus 13. All right, now if I have two semicircles, well, a semicircle is a full circle cut in half, 360 divided by 2 equals, yes, 180. So we'll just take these 3 slices that the students ate and set them equal to 180. I'll start with the purple 109 only because that's where I started when getting ready with this one. Then we will go on to the pink and we will add the 4x plus 8 to it. Then we will add in teal our 6x plus 13. And I'm beginning to run out of real estate. And set that equal to, well, only 180 this time. So if you have a diameter and we can cut the work in half, cut it in half. Give that to your teacher. All right, here we go. We have written the equation. Let's combine like terms. Again, I always like to start with our variables here. Our 4x plus 6x gives us how many x? Great job. 10x, 109 plus 8 is 117. 117 plus 13 is, yes, 130. Set that equal to 180. Step 3 in blue, subtract constant term from both sides. And again, if this was a negative 130, we would add 130 because we are now playing the game of inverse operations, the game of opposites. And what we do to one side, we will continue to do to the other side. Our 10x, just go ahead and bring it down. There's nobody down there with it. 130 minus 130, that's going to cross out. There's nothing left. 180 minus 130 is a 50-piece nugget. And we will divide by the coefficient, the letter or the number in front of the letter. 10 divided by 10 is going to give us a giant 1 on an angle, because how many x do we see? Just 1. Equals 50 divided by 10 is 5. Go ahead and circle that. All right, so this one and the next one you will use on your second independent practice, but that's up to you to determine as well. And for our last one, again, oh my goodness, we have how many slices? 1, 2, 3, 4, 5 slices. But again, Mr. Richards is like, guess what, guys? I'm going to come in and I'm going to eat half of that pizza. All right, that's too much. I do want a little more than that this time. All right, there we go. Now, 110 plus 70 is 180. We have a diameter, all right? It starts at the edge here of our circle, cuts through our center point, ends up on the other edge. It does not break off. That could not have been our diameter because that breaks off. This could not have been our diameter because that breaks off. That will create your central angles. But if Mr. Richards already ate half the pizza, that's too much. Let me go ahead with our gray. Well, he already ate all of this. All right, all this is gone. This 110 degrees plus the 70 degrees is gone. And again, what's a semicircle or half of our pizza? It is 180 degrees. Great job. Excellent work. All right, this time I'm going to highlight our 3x first. And our 3x falls upon the arc. And on the inside for our central angle. Ooh, that's too much. We're going to put 3x. Beautiful. Great job, crew. I am going to highlight our central angle of 83. What do we know about that central angle? Its arc is also the same because how many degrees this opens till will determine how open and how great our slice that another student ate, which is also 83 degrees. Yes, I'm not putting the degree symbols. I'm trying to make this somewhat quickly. I am going to highlight our arc of 10x plus 6. And its central angle is also then, yes, 10x plus 6. Let's go ahead and write this out. And this time I am starting with a 3x in the light purple. We will add the 83 to it. We will add the 10x plus 6. And we will set that equal again to not 360, but 180. We are cutting the work in half because half of the pizza's already gone. And then we can start thinking about creative shortcuts later down the road. Let's get those minds in motor mode. All right, step 2, we will combine like terms again in orange. I am going to circle our 3x. I am going to circle our 10x. 3x plus 10x gives us how many x, guys? Yes, 13x. I am going to box our 83, and I am going to add 6 to it. And what do we get there? We do, it's 89. We will set that equal to 180. And then we will subtract the constant term from both sides. We need to get that 13x by itself. We need to isolate it. It's hanging out with plus 89. Let's get rid of the ditka. Let's subtract 89 from both sides. As you can tell, a couple of videos. I'm from Chicago here, as I do reference some of those numbers to their players, because 180 minus 89 gives us the Dennis Rodman of 91. And our last step is to divide by the coefficient. Divide by 13, divide by 13. 5 is 65, plus another 26. X should equal 7. Go ahead and circle. And again, guys, that should be your note. That's your last one. My crew dominate today. Crush for the sub. Let's go.